Testing, testing, 1, 2, 3. All right, welcome back, and we are going to do a depth first search iteratively on this graph. Now, this graph is pretty simple, but I'm gonna go over it just because I built it slightly different than how some other people may have built it. So the main thing about the graph is it's using an adjacency list. No surprise there, but I'm using just a plain old JavaScript object and defaulting it to be nothing. I got the add vertex and add edge. I then create the graph with the variable g, and I create a graph. The graph looks like this: A, B, C, all the way to F, and the connections and the adjacency list looks like this. Sweet. All right, so now we're gonna go in and do a iterative depth first search. Let's start that here. We're gonna put that on the graph class. So let's just call it DFS, maybe lowercase I DFS for iteratively, and just in case I do this again and do it recursively. All right, great. So it's gonna take in a start because you got to start somewhere. So we'll probably start at A, but we'll leave that up to this parameter here. At the very end of the day, we want to search everything in the graph, and it's going to be given to us at the end of the day, at the end of the function, in an array. So let's say return results. Results is an array that we do not have right now, so let's go ahead and create that. Const results equals boom. Perfect. Now we're going to need a stack, which is a first in last out data structure. So we're gonna come and make a stack because we're gonna need that later, and that's how we're gonna populate the stack and then pop it off into the results, and that's going to at the end of the day be our results. Okay, cool. So with the stack, the first thing in our stack, we can default it to be our start, so it's A because we want to have that in our results later. Cool. So that's nice. And then we have to do one more thing, which is keep track of the visited. You can keep track of the visited in either an array or a map or a dictionary object. I'm going to do it in an object. Const, what I call it, say that I was going to do? Visited. Sweet. And since we are visiting something first, we can say visited of start equals true. So we're going to use trues and booleans to say what's visited, what's not visited, and that's how we'll check later when we do some conditionals on it. And something that I want to create right off the jump is where we're at in like the search of things. I don't want to give it value, but I just want to set that variable aside. So I'm going to do a let current vertex. I'm gonna set that equal to nothing. Cool. Now we want to do a while loop. While there's something in the stack, let's get to work. So to start that while loop, while there's something in the stack, let's do something. We can do while stack has length greater than 0, or it's true. If anything above 0 will be truthy. Then let's do some stuff. Cool. The stuff that we need to do can be broken up into two parts. One, we want to hold the value of our current vertex, and we're going to get that current vertex from our start. And then from that current vertex, we're going to push it into results. So the flow of things goes, let's see, stack, how do I want to say this? Stack, we want that to flow into results. Cool. Yeah, I think that makes sense. So current vertex is going to be equal to the stack dot pop. Just get rid of that last thing. And then with that last thing, which right now is going to be like A for alpha, we want to put that into the results list. So results dot push of alpha. Oops. Alpha is the hard code. Current VTX is what we want to push in. Now that's nice, but that's going to be a pretty boring while loop because we're not adding any more information into the stack. So we want to add more information into the stack. So essentially, we want to go to the adjacency list, look at the keys and say, is the keys? Yeah, look at the neighbors and say, okay, if it's not already in the visited list, push it into the stack, and then we're going to push that stack into the results list. Perfect. All right, let's go ahead and do that. So here we are going to do this dot adjacency list. We're doing a this because I didn't do map and I used a constructor and whatnot. This dot adjacency list, which is going to give us this whole thing right here. And then I want to do adjacency list at the current vertex. So in the first iteration of this is going to give us the connections between alpha, which is B and C. And then we're going to do a dot for each to iterate over that value for each. We want to say, you can call them neighbors. Since I'm going to break it up into multiple lines, I'm going to use the curly braces. And we want to do some checks. So if it's not in the visited, add it to the stack, because together on the stack, we're pushing the stack into results, which you can see here. So stack results. So let's do some stuff. If it hasn't been visited, so check the visited data structure of that current neighbor. I feel like I did that wrong. Nope, looks right. Then we're gonna do some stuff. So again, visited neighbor, we're checking if B or C has been visited before. And we technically are visiting, so we want to scratch it off the list as we iterate over it. So we're just going to set that to true. Visited of neighbor is going to be equal to true. Basically, put it on the list saying that we visited it before. Excuse me. And then we want to put it on the stack so that we can push that stack into results. Push neighbor. Cool. And I already returned results. That's the first thing that we did. So this while loop will run while there's stuff in the stack. We keep stuff in the stack because we're pushing it, pushing the neighbors onto the stack. And then if it hasn't already been visited, we're pushing that into results. And that should do it. So to check if we did that correctly, let me make sure my stuff is on the screen. We can run iterative depth first search, and then we can run that on A. Neighbor is not defined, because I probably spelled it wrong, because that's a hard word to spell. Yep, neighbors here, boom. Sorry, I can't spell. But anyway, yeah, so we have A, C, E, F, D, and B, because we're going depth first. So that's A to C to E to F to D to B. That has been iterative depth first search. This has been Jeremiah, signing off and signing out. All right, bye.